Today I'll talk on topic of implementation of STEC in military explosive buildings. So I will cover the topic in the following heads. I'll first give a brief on the STEC and CEFIs and the CEFIs pamphlets, the storage principles that are involved, the basic terminologies, the quantity distances and the design criteria which is involved as per STEC. The Center for Fire, Explosive and Environment Safety is organized by under the Armaments Directorate of DRDO. Now, the key role of CEFIs is it works in the area of explosive safety, fire protection and environmental safety. One of the functional areas is that it helps in the siting of explosive processing and storage dumps and the design, testing and evaluation of the safe explosive storage houses. Why STEC? STEC was Storage and Transport of Explosive Committee. What is the policy of this committee? The manufacture, the handling, the storage, conveyance, use and eventual disposal of military explosives are operations which present inherent risks to people and the property. So therefore, the Ministry of Defence through its Storage and Transport of Explosive Committee, that is STEC, issues certain pamphlets and ensures that these explosive buildings present a minimum degree of risk in case of an accident. Now, what is the aim of STEC? The aim of STEC is to regulate and control the storage, transportation, all these activities that we saw, that they possess a minimum damage in event of an explosion. That is, they are protected to a predetermined practical standards. The scope is that the ammunition explosive safety standards shall be considered minimum, that is provided in the STEC pamphlet, and it should be adhered and applicable to MOD ammunitions and explosive facilities. There are almost 24 STEC pamphlets that are issued for various purposes, that is the construction, firefighting, air conditioning, lighting, etc. etc. So these are applicable to the various buildings as per their requirements. Now, the STEC explosive committee. Before we even go into it, let me tell the latest STEC is the 2017 STEC regulation. So this is basically based on the UN system of classification, and in this STEC, it is almost rewritten with the new test and the result that they have come out. They have come out with innovative structures for explosive buildings. First of all, as per STEC, the explosive are categorized into 6 hazard divisions and 13 compatibility groups. So, depending upon their characteristic and expected behavior when they are suitably initiated. So, what is that? Why should they be categorized like this into hazard divisions and compatibility groups? Because the advantage is that the user, it gives them a flexibility to select the best option so that to store together so that there is an optimum utilization of the available land and the financial resources. So who is this applicable to? The STEC regulations, these regulation and distances, these are applicable to all explosive facilities under Ordnance Factory Board, DGQA, DRDO establishment and all the 3 services. Today we will talk about specifically STEC pamphlet number 1 and STEC pamphlet number 3. The STEC pamphlet number 1 gives the quantity distances. That is the distance that should be maintained from the potentially explosive site. So this shall be applicable to the new facilities, but what about the existing facilities? There might be existing facilities which do not comply with standards, but these shall be allowed for the balance of their useful life only when it can be demonstrated clearly that the redesign or modification is not feasible or the quantity of explosives cannot be reduced due to operational requirements. However, a deviation sanction for these buildings should be obtained from the competent authority. So these quantity distance, what are these quantity distance? These quantity distance are basically a sensible balance between absolute safety and the practical considerations of cost and operational requirements. So why is mixing of ammunition and explosives required while storage? The highest degree of safety can be achieved when each item of explosive is stored separately. But however, such an ideal storage is generally not feasible because of the cost constraint, because of the space constraints, and various other practical reasons. So, a proper balance of safety and other factors frequently requires the mixing of several types of ammunition and explosives in storage. So, but however, dissimilar materials or items that present positive hazards to this munition should not be stored together. For example, like ammunition and explosives with flammable or combustible materials or acids should not be stored together. So, the mixing should be subject to these standards and to the compatibility groups. Then this will ensure that safe operations and promote overall storage efficiency. And as it said, this is already based on the UN International System of Classification. This is devised in order to promote the safe transport of dangerous goods, which is extended almost universally. So the basis of the system is the classification of goods by the type of the hazard that is involved. So coming to the hazard division, as per UN classification, there are 9 types of classes. But the class 1 comprises of the explosive substances and articles. So class 1 is further divided into 6 hazard divisions. Some of the basic terminologies are that if they may be these explosive items, if they may be stored or carried together without significantly increasing the probability of an accident, then they can be said to be compatible. So the description of these compatible groups, they are grouped from A to N and S. Hazard classification code. So based on the hazard division and the compatibility group, the hazard classification code is given. Now let's see what hazard division is. Based on the expected behavior when ignited, explosives are divided into 6 hazard division. The explosive is come under hazard division 1.1. They will produce mass explosion, blast, high velocity projections which result in severe structural damage and other projections which are relatively low velocity. Hazard division 1.2. In this, these explosives result in a projection hazard but not mass explosion. The hazard division 1.3. This will result in mass fire hazard and a minor blast hazard or a minor projection hazard. Hazard division 1.4 will not result in any significant hazard, and there are no explosives which are classified under hazard division 1.5 and 1.6. So, now the potential explosive sites. What are these potential explosive sites? These are buildings, stocks or vehicles in which explosives are permitted and are stored, which are a potential risk to individuals and property. Those are called potential explosion sites. Now, it is the responsibility of MOD headquarters to ensure that such sites are located sufficiently clear of the building stocks, roads, railways and other places frequented by persons, and to ensure that the minimum risk to life and property is there by locating them suitably. This clearance distance that is required from potential explosion sites will depend upon the maximum net explosive quantity that is stored in that site. So, based on these, there are 2 kinds of quantity distances. These are inside quantity distance and outside quantity distance. And there are 2 types of inside quantity distance. These are what we'll see. One is storage inside quantity distance and second is process inside quantity distance. Storage inside quantity distance is the distance that is minimum permissible distance between a potential explosion site and the storage sites that are containing explosives. Then the PIQD is the distance that is the minimum permissible distance between a potential explosive site and the process building which is located nearby. Now, there are 2 kinds of outside quantity distance. What are they? They are public traffic route distances, that is PTRD. These are the minimum permissible between a potential explosion site and a public traffic routes. Then the second is inhabited building distances, that is the IBD. What are these? These are the minimum permissible distances between a potential explosion site and inhabited buildings or assembly places nearby. So, it is very important that, and it is a responsibility of the Ministry of Defence to restrict any construction of any public utility within these areas, that is up to inhabited building distance. So, The compliance may be ensured by concerned military establishments by forwarding safeguarding maps of their establishments to the local state authorities for issue of necessary government notifications to that effect. This is a typical layout of an explosive site. So wherein we can see that the bigger, these are the storage buildings, the smaller circle continuous lines, these are the SIQDs, that is storage inside quantity distances, and the bigger circles which we see, these are the PIQDs, that is process inner quantity distances, which are required from a process building. And this shows typically the outer quantity distances, that is the distance that is required from the inhabited buildings. Now, we will come to the STEC pamphlet 3. The STEC pamphlet 3, it covers guidelines and technical requirements for design and construction of explosive storehouses, process buildings and traverses. There are two types of traverses, that is vertical inner face traverse and natural angle traverse. Now, we have seen what is potential explosion site wherever the explosives are stored. Now, there is something called an exposed site, that is ES. What is an exposed site? The exposed site is the site, that is, it might be a storehouse, it might be a truck, it might be a railway line, it might be workshops or any inhabited buildings which are exposed to the effect of the explosion which happens from the potential explosion site is called the exposed sites. Now, this STEC pamphlet 3 gives various criteria for site selection. What are they? It says that the site should not be susceptible to erosion. That's the first thing. Second, the site should be free from underwater courses. The third is it should be well drained and not prone to flooding. The fourth is the site with continuous rock strata. It should not be selected because the possible transmission of shock waves to excessive distances. The site should be within the easy reach of railways, main roads, public transportation and sources of labour and supplies of water, fuel and electricity. Then it lays on general constructional requirements. So the main principles to be kept in view in the construction of explosive storehouses and magazines are: first, the use of inflammable materials should be avoided. There should be no exposed iron, steel or aluminium in the nearby because these are sensitive to spark or friction. The third is the orientation should be fully planned to avoid direct sunlight falling on any of the ammunition or explosive package. Advantage of the prevailing wind wind direction should be taken so as to facilitate effective ventilation. The plinth level of the building of course should be above the general flood level. An untraversed explosive building shall be provided with 5-meter wide hard standing to serve as a fire break. Now, what are the different types of magazine? Based on the hazard division, the explosive storehouses or magazines can be divided into hazard division 1.1, 1.2, 1.3 and 1.4. And based on the type of construction of storehouses can be classified as bunker type storages, igloo, that is box type storages, underground storage structure, rocket storage buildings and so on and so forth. The general constructional criteria we will see. First, for floor, generally for all storage houses, floor should be well finished, concrete, free from cracks and crevices, and it should be able to support a load of 10 tons per square meter. With respect to walls, the walls should be finished off smoothly and free from cracks and crevices. And the height of the wall should be such that there is a clearance of 60 meters between the top of the explosive stack. And in case of buildings where crane is being used to lift, then the height of the wall should be sufficiently increased. The roof is by and large a well-rendered RCC roof of 15 centimeter thick and the suitable slope should be provided. And doors, the location of the doors and the size of the doors will depend upon the users and the actual requirements. But in any case, at least 2 doors should be given so as that one acts as an alternative exit. And the doors should always open outwards and they should be fire resistant. Usually it's a steel door which is painted with approved fire resistant paint and it shall be minimum 12 mm thick. Windows are not permitted in the storage houses. Coming to ventilators, storage houses are provided with a special type hit and miss type Z vents. So adequate number of these ventilators are provided. And also in addition to this, loading platforms should be provided so as to meet with the requirements of rail or road service. So suitable covered platform, loading platform should be provided. Coming to the size of the buildings, it will depend upon the user's requirements and the type of ammunition that is stored in the building. Coming to approach roads, these magazines may be served by roads. When they are served by roads, an individual loop or road leading from the main road should be given to each magazine. And when it is rail served, a number of storages may be served by at one spur. So this shows a typical Z vent which has an inflow of air from the higher level and the outflow like it at a lower level. This is a bunker, typical bunker, which has a concrete structure filled with earth above. And this is a plan of igloo. The special features of the igloo are that it has got earthen towers on all four sides, and it is built of lace reinforced concrete walls, and it has got head-shaped columns and beams which bind the building from all sides. And this is a unit risk principle building for 1.3 hazard division, in which all around a 10-meter PCC is given for as a fire break. And this picture shows a typical wift and nat. This is a typical wift which has a vertical RCC wall with sand dunes behind. And this is a natural angle traverse which has had sand filling on both sides. And how the height of these traverses are decided. When we take a 2-degree angle from the storage stack to that building, the height at which it reaches the level will be the height of the stack. And this is a typical blast wall in front of a weak section. When the weak section explodes, the explosion is contained by this thick RCC wall which acts as a blast wall, prevention wall. And this is one of the magazine which is served by road on both sides. And this is a typical magazine which is served by rail on one side and by road on the other side. Now, we will see the design principles of process building. So far we saw the design principles involved in the storage building. Now we will see about the process building. So what is a process building? A process building is a building in which explosives are worked upon or manufactured, and this will include facilities like ammunition workshops, pilot plants, development production units, explosive laboratories, preparation room, etc. So the main aim of the process building design is that it should provide maximum possible protection to those working within the building. The walls of a process building of hazard division 1.1 shall be of 22.5 brickwork, but it will be invariably shielded by vertical inner face traverse, but in which 68 kg explosives up to is handled. An RCC wall is adequate thickness is sufficient, which itself will function as a container traverse. Then the walls of UN hazard division 1.2, 1.3 and 1.4. For these, it will be a 34 centimeter thick brickwork, but a special feature of the 1.3 hazard division is that it will have a weak section, since these buildings are normally untraversed. So what is a weak section? They are sited in such a manner that the doors, windows and weak sections of one building are not facing those of another building. Alternatively, it will be practical to interpose a traverse building in between two buildings which have weak sections. And about the exit, as we saw already, there will be at least minimum of 2 exits, one to really for an emergency exit. Regarding recommendations, since STEC very specific to MES and explosive buildings, they should form a part of the YOBW course for the young officers who join MES. The second is that the digitized survey plan of the sites of these military establishments should be made available so that a proper and accurate site planning can meet the requirements of the quantity distance requirements as per STEC. Thank you. Thank you so much for your patient hearing.